Hi everybody, in this video we're going to start talking about angles and then also radian measure. So first I just have a quick drawing of an angle, and an angle is created when we have two rays that meet at a point, and that point is called the vertex. So remember, a ray is sort of like a line, but it only goes on forever in one direction instead of both. So you have a ray here and a ray here. That point that they intersect or where they meet and end is called the vertex. And then the angle is created in between those two. We often use a symbol that looks like this. It looks like a zero with a line through it, but it's actually a Greek letter. It's called theta. So we do use that oftentimes for angle or other Greek letters as well, which you'll see. And also there is a direction to an angle. So you'll notice that I had drew an arrow this way, which means that the angle is formed from going from this side to the other side, because you can form angles in different directions. The side that you start on is called the initial side, and the side that you end on is called the terminal side. Initial means start, and terminal is where you end. So that is the start of an angle. Now, oftentimes we will see angles that are in excuse me, standard position. And you're in standard position if the vertex is at the origin and also if the initial side is on the positive x-axis. So for instance, one example could be, here is your initial side, and then maybe we form an angle this way, and we're going in this direction. Okay, so that's one angle. I'm going to call this angle alpha, so that's a Greek letter A. Another example of an angle that's in standard position is something like this. So again, you're going to see that vertex is at the origin. The initial side is on the positive x-axis. I'm going to go this way. Now, again, you could go all the way around to the left, or you could go backwards and go in this direction. And I'm going to call this, we'll use theta again. So again, here's your initial side. This is where you're starting, and we're going down this way. So the direction is important here. Something that moves in this direction, so you're going counterclockwise, is going to give you a positive angle. So the value when we actually get to that will actually be positive. And when you go backwards, so when you move in a clockwise direction, you actually get a negative angle. So this would have a negative, again, when we start attaching numbers to the actual measure of the angle. So the direction tells you positive or negative here. So that's really important as well. So here, in both of these cases, you do see that our terminal side is in a quadrant, right? So if you think back, this is quadrant 1, 2, 3, and 4. So a lot of times your terminal side will end up in a quadrant. So it lies in a quadrant. But it could also occur actually on one of the axes. So for instance, so I'm going to draw another positive angle here. Let me move my screen up a little bit. Here's my initial side, and I'm going to go in this direction. So I'm going to go almost all the way around. But here I ended up on the axis. So when you see that, the angle in this case is called a quadrantal angle. And you probably won't hear me say that too much, but just noting that that final terminal side actually ends on one of the axes rather than in a quadrant, like we're used to. Or I shouldn't say we're used to, but I feel like we tend to probably see these a little bit more, but you can also end on the axis. Now, we can measure angles in either degrees or radians. So actually, how do we get the numbers, right? So it's just like having different units. So for instance, let's say when I was measuring something, I could measure it in feet, I could measure it in inches, I could measure it in meters, right? So I could use different units there. And it's the same thing here between degrees and radians. So as I was saying, we can measure angles in either degrees or radians. They're different kinds of units. And what I did was I just kind of paused the video and drew out 4 of the main angles that we tend to see, or the main types. So the first type is called an acute angle, and that's an angle that is between 0 and 90 degrees. So 90-degree angles are one of our main kinds of angles, and they're just really helpful because what they do is they form this kind of perfect straight up and down association there. So when you have that perfect vertical with that perfect horizontal, that creates a 90-degree angle. And we will use this little square symbol to represent that as well. It's also known as a quarter rotation. So we typically think about angles in terms of circles around the plane. So the whole way around, to go from, let's say, the x-axis around to the x-axis again, would be a full rotation. So here, this is a quarter rotation because you're going a quarter way around that plane. So an acute angle is strictly less than 90 degrees. An obtuse angle is something that is more than 90 degrees, but less than 180 degrees. So your 180-degree angle is called a straight angle. That's this one right here. And it's a perfect horizontal line. So you would start on this ray and then go to the other side. So you're doing a half rotation or a half turn. If you think about this as a plane, right? The XY plane, you're going halfway around the plane. So that's your straight line. And again, an obtuse angle is in between a 90 and 180-degree angle. So those are the 4 main types that we tend to see. And of course, there's different ones, right? So one example of an obtuse angle could be 120 degrees. Another example could be 165 degrees, etc. So anything in between would be fine there. And these here are, just so I should clarify here, I'm giving you this information all in degrees right now. So this little circle symbol here is what represents that degree. And that's probably how most people are used to learning it. If you've learned it in high school already, some high schools will do radians, but most students, when they first start learning about angles, they start with degrees. So we're using that unit here to show them. Now, one other thing to note about degrees, I greatly apologize. My allergies are really bad right now, and I'm trying to record these so that they're ready for our class. So one thing before we move on to radians is, again, another thing about degrees. So you can also have fractional parts of degrees. Right? So maybe it's not just 120 degrees, maybe it's 120.5 degrees or 120.532 degrees, etc. So we could again elaborate there and go further out into decimals. And a lot of times decimals are fine. So when we're doing work, decimals are perfectly fine with degrees, but there is another notation as well. And they're called minutes and seconds. So I'm going to give you one example here. So 31 degrees, 47 minutes, 12 seconds. So this notation here is for minutes. And then this notation here, that double line, is for seconds. So how do you convert this into a decimal? We can use a pretty simple conversion here. So the 31, the degrees part stays. And then for the next part, what you do is you go ahead, and if you think about minutes, right, there's 60 minutes in an hour. So you divide that by 60. And then for seconds, we take that and we divide it by 3,600. And think about, if you talk about hours, right? If there's 60 minutes in an hour and 60 seconds in a minute, 60 times 60 is 3,600. So that's where that comes from. And then I would use our calculator here. So I just take out your calculator, plug these in, and what you get is about 31.787 degrees. Okay, so You can go back and forth between the two notations there. If you have something that's given in minutes and seconds, we can very easily change that into the decimal form, and you can do the same thing going both directions. There's also a lot of online tools that can do this for you too. So if you're getting stuck, you could always just search either on your calculator or online for a converter that can go between minutes and seconds and decimals. All right, so I'm going to stop this video here, and then we're going to pick up in the next video starting with radians.